Thank you for the invitation back. That class, I do teach over in that department, so that's probably where he's getting all his information, so that's interesting to know. It floats. Now, that must be the quickest way to lunch is on the back row, is that what I'm? Okay. Can you hear me all right, or I need to get a mic?
Yeah, I can hear
You all right? Any problems, if I start whispering or something, raise your hand. All right, Delana is gonna assist me to start out with. I have a very simple proposition that I want you to tell me all you know about it. And that is, what is an asset? Speak up.
Something you own?
Something to spend money on.
All right, something we own and something we spend money on.
But it gives you more money, it's not a liability.
It gives you more, like a return.
Value.
Yeah, it
Okay, it does
increases your
add
net
value,
worth.
maybe. What else?
It could be the building blocks of something bigger as well.
Yeah, it could be the start of something bigger,
Could be a resource.
could be a resource. Is it always a positive value? Can you have negative assets?
Yeah.
Yes, I have many of them.
Okay. I would make a joke about that, but I will not. All right, when you see the list of assets, you get a pretty good idea. These are all really representative. The next list I want Delana to write on is, what are the assets that relate to what you do in IP&T? Is that right?
Mm-hmm.
Anyone, you don't deal with assets?
You don't use those terms usually.
Yeah, so.
Okay, look at the list of terminology. Do you do anything of value? Do anything that,
No.
that costs? Anything that furthers along a program? Do you do anything that has a life cycle? We didn't put that down, but it's gotta have some kind of a life cycle, then you gotta look at it and renew it and get it up to date.
So maybe like an instructional product that we're working on.
All right,
like
let's
curriculum.
just say products in general.
Software?
Tools we use.
What?
Tools we use.
Tools, yeah. Can you do your job without a computer?
Maybe.
Maybe. You may be selling to yourself, but maybe. Yes?
In a lot of the projects I've worked on, a lot of the assets are the people I'm working with, and their prior skills and knowledge.
Okay. Is there an end result in what you do?
Mm-hmm.
What is it?
Deliverable?
Yeah, some kind of product.
Say again?
The deliverable?
A deliverable?
Yeah.
Does that have any value to it? Is it
Mm-hmm.
you measure that value?
Yeah.
So I think, thanks, really, that's all we're going to have time to do with. I think that, well, let me just ask you some questions. Is a computer program an asset?
Yeah.
Okay. Certainly the hardware is an asset because you buy it, but the program is. Does it have a life cycle?
Mm-hmm.
Do you know how long it takes to wear out? How do you know when to replace your product?
When the computer starts shutting down and doing updates.
Then you replace the hardware. The software may still work. But how do you measure, can I just say, just as a parenthetical, the problem I had in 1981 when I was asked by the trustees area to come to BYU and write a program that would tell them at that time what it was going to cost them to run this university the next 40 years. We had trouble doing a budget for 2 years, let alone 40 years out. But they said, we just want to know if we can afford BYU the way it is or it wants to grow. Because the church was just growing like wildfire, and they just didn't know if they could afford us, and so they needed to answer to that question. Well, prior to that, we didn't know what the product life cycle was. We didn't know what the cash flow was needed to take care of that product, using your terms. And so we had to do some investigation as to what and where we were at. And so I think that, how many were here on the last lecture? Oh, good, I don't have to cover so much. I put it back on just to kind of go through some stuff quickly, to build to where we were at, and then to finish off the lecture, hopefully. But there's gonna have to be some, a little bit of discussion to make us there, or we're gonna have a really short discussion, all right? So I would appreciate any questions, but think in terms of products that you do. What gives you the ability to design and create, the ability to construct, the ability and what it takes to do maintenance and operations on that product. And then when do you know when to recapitalize it or replace it or go on or move on or change or do retrofits or whatever? Because in every asset there is that element that takes place. And you gotta determine it. What's the life cycle of that projector? It's projecting.
5 years.
Yeah, probably.
Andy, how long has this projector been in?
Since the summer.
And how old was the old one?
The old one probably was here when Adam was
Okay,
chasing out the garden.
so Eve has her prints all over this, right?
Yeah,
Okay.
is it not working correctly?
No, we're using it as an example.
Oh, good.
What do you think the life cycle of it will, the new one will be? That's what he's asking us.
Yeah,
How long will
that's a
it
good
last?
question.
I wanna know the life, at the age of the old one, you know that about, it's probably got to be 10 years.
Yeah, it was a huge.
Because the last time we remodeled this building, I think, was when we put it in. And that's 10 years ago, that should have been a dinosaur in terms of technology.
Yeah,
The one before that was probably about 10 years too. It was a beast.
I didn't hear you.
So I was saying the one before that was probably about 10 years as well.
Yeah.
It was like the size of a small.
When we
car.
first started inventorying, we put projectors at 10 to project cash flows and so on. We put screens at 25 because they, unless you're ripping them or something, there's really not a lot that goes wrong with them. What do you think the life cycle of the chair is that you're sitting in?
10 years?
How long?
7.
Who said 20?
I retracted that statement. Sorry.
That means your kids are gonna be sitting in these chairs.
the shorter the
I
better,
would
actually.
put it past you right here.
They've been here since 2005, I know that.
Wow.
2005? And when these chairs were, so it was the remodeling time. That made the projector even, well, no, a little older than 10. Have you ever thought about how your creativity becoming a product, what its life cycle is? Have you ever thought about what it costs the owner, not only just to have you create it, but to take care of it and then to replace it again? That's what we're all about. We call it total cost of ownership because that's the name of all of the costs that relate to an asset. The initial cost is the cost to build or create or do the product, but it's a one-time cost. Then there's money put aside for maintenance, which is an ongoing cost that you ask for every year so you can maintain the product. But then the last one is a periodic cost. You only replace it when you need to replace it. And so those are the three blocks of costs that make up total cost of ownership. But I would dare say that there isn't anything that's physical in nature, either portable or fixed asset, that doesn't qualify for total cost of ownership. Can you think of anything? Name it and I'll challenge it. Yeah,
I'm just wondering, Doug, is there, when they build a building at BYU, how much, what percentage of the total cost of ownership of the building is actually building the building, designing and building the building? And what
Okay.
percentage of it is the long-term cost?
if we take the total campus, we run at about 28% of the total cost of ownership is in construction. And so let's just round it up to 30, maybe 33, and say 33, 33, 33, because the rest of it balances itself out. But it's different depending on the buildings. When you build a big one like the practice field that we did, it was probably about 40%, 30 or 40% of the total cost, because once you get a big open area, you just gotta replace the turf every 10 years, you've gotta do some painting and a few things, but there's not a real lot to do, and it should last a long time. And so that makes it a little better, but on the average, we're about 28%. I don't know if I can dare say what that new what do they finally name it?
The life sciences.
Oh, life sciences. They made it good. When we were designing it, it was the biology building, something, biolab. But let's just round that up to $100 million. So what's the cost of maintaining that building over a 75-year life? And if you take that, or you can take that number and say it's really about a $300 million investment. But you're building it for, say, $100 million. Those aren't good numbers, but that's rough. So, give me an idea what the cost of creating one of your projects is.
Because we take into account faculty time and
What somebody paid you to
university
do.
resources and.
How much did somebody pay you to do what you're doing?
Nothing.
Let me give you an example from my own experience in industry. The cost varies with the tools and the technology of the time.
Yeah.
So we did one project for Northwest Airlines.
Mhm.
It cost $750,000. $750,000.
Yeah.
They liked the product, so then American Airlines saw the product and they wanted one like it. But in the interim, the technology of the tools had changed, and the second project only cost $65,000. And then the technology changed again.
That's
and-
why Northwest went under, right?
Probably a big part of it. Scandinavian Airlines got a third one for $35,000. But it all depends on, we had learned how to do it over the course of those three projects, and our tools had advanced. But if we were talking about a team-developed instructional product, let's take a figure of $100,000 to develop the product.
Okay.
That's video, programming, art, design time, subject matter expert time, equipment, facilities, that kind of thing.
How long would that product last?
At current rates of change in our industry, probably about 3 years to 5 years.
Is it something you could retrofit and extend its life by touching it up, or is it gone and done?
Everything depends on how you design the product.
If you use layers, you could.
The first product, you know, the first product that we created was a monolithic program that was so large in the computer of the day that we had no way to transport the program off the computer. So we had to take that computer around with us wherever we were going to demonstrate the product. The second product, we learned we learned to build it smaller and better because of the new tools. The third product, we learned that we could use the same basic architecture of the event architecture, but we could make individual problems in this simulation product independent of the base that ran. It was like record player versus record, okay? We could take off one record, put on another record, and play the new record because we had modularized it. So, there.
Well, so the question would be on that, Northwestern obviously has a bigger write-off, you might say, or maybe even more of a cost of ownership, but you could also look at it as, this is a product set that we can retrofit and we can bring up to date, and probably Northwestern could use your new one as well as their old one, maybe. I don't know where your structure is, but let's just say you build a super design and it was carried over, it was the technology and those advancements that made it, plus you enhanced it a little as you went along. So the idea of having a product, and then even though you may duplicate it and change it, it's still, let's say, basically the same product. That's kind of how we do buildings. We build a building, but we'll never build the same building twice. Now, some would look at the heritage and say, wrong. They look to me like they're built the same. We learn from every building we build and apply it to the next set of buildings that we build. So if you really want the best heritage hall, you wait till the last one's built and move in there. Because that will have the latest of everything, all the things we learned and all the bad accumulated that really changed it. And we do that by modeling, and you do it the same way. And by making sure that the design that goes out has a basic look to it that's the same as the other heritages. I mean, just looking at it, you'd never know, but the things behind the scene or the life cycle stretches we can do with plumbing or heating, or maybe there's a new technology we can use to make it even easier, that'll all come as we build the buildings. And then the last one will get it. Well, some would say, gee, you build them all the same. All you had to do is take a paper cutter and just do it. It's like they say about chapels and churches. The church just makes one design, and then they use it 40 times, and then they make a second design, and then use it 40 times. That's not how it works. The church is learning continually, every building they build, how to make the next one better. And that's the continuous improvement that comes in. And why is that so important? Anybody got feedback? Why is it important? Yeah.
Well, in some respects, the change of cost from $750,000 to 35 was a function of technology change, but undoubtedly there was also a learning curve change that was part of that decrease in price. So if we can build a bio lab building for $100,000, maybe we can build an engineering building for half that.
Yep. And that's how we look at it. We track everything that we have an improvement on and put it into our next plans. And so the last building we built on campus is the best we know how to do, given all the other buildings we built. And architects and engineers hate us, sorry, if you're in the design side, because we look at the durability of a asset over its life than we do about how pretty it looks the day it's built. And we get complaints all the time about how sometimes we're so stark looking and so on. But we're actually building it the cheapest with the longest life cycle cost of owning. And we're actually doing, if this building is $100 million, on another campus it could be $150 million, because of some of the things that you learn and do and apply. Now that gets into total cost of ownership. Total cost of ownership is what the owner's gonna pay for the whole time you use the asset. Yeah.
So does that mean that when the buildings are put up, they have an idea about how they're gonna retrofit it?
Oh, yeah, we build retrofitting and we build additions into most of our buildings. We actually know where we wanna go. Now, we don't sometimes do it that way, but you have to do that to get the mechanicals and all the utilities right.
To what extent does the idea of modularity play into the design of a building?
We think, this is just my thinking now, probably more than BYU's, we think in the future, as an industry, we will buy modular buildings and have them put together. So as we plan them, they're building them. And then when we get through the plans, they'll just finish them off and bring it and install. I'm talking about walls. They'll have all the power in the walls and in the ceiling, all the light holes for the, everything's done. So you just come in and you bring and you put it together because you save so much money not building it while you're there because of everything you can do in a shop to speed it up. You take advantage of all that. So someday you'll watch a building and it will actually be done twice as fast as we do now. And it will actually come together like a modular look. But it'll always have some feature to it or some look to it that ties it into our whole campus. So it's not gonna just look like a bunch of boxes.
But,
Yeah. You had another question?
well, so my question is, if a new technology comes along,
Mhm.
can you undo the building, or does it come, since it's modularized in the package, prepackaged, does it make it harder or easier to use it in a different way when a new technology emerges that you can't
So-
even foresee right now?
It's all back to how much you're willing to put into design. Right now, we design all of our buildings so that we can take care of about anything that comes along for the next 50 years. Now, how do we do that? Well, instead of putting just a conduit in for a plug, we build the whole building with a set of trays that you can run cables or whatever you need to run to any room without going through and showing on the outside of the wall. We sometimes have to show it because we didn't plan very well. I don't see them around here. But you'll see these little Romex things that are these outside covers for power. It's usually in the older buildings. But you cannot plan a building for today because by the time you get done, it may not even work in today's world. You have to be ahead of the score and ahead of the game. Technology has pushed us more in that area, but we were doing all of the utility work and everything way before technology came along, so that you can get the idea that this place can be even remodeled and renovated and updated with nobody even seeing what we're doing if we do it right. Yeah.
One time you described to me the planning for the life sciences laboratory areas and how you calculated the space between the drop down.
Yeah.
Could you just describe that?
There's a term for it, it's a space that you build in between the walls so that you can do anything you want and put any utility you want wherever you want it. And so we did that in the science building. There's about I don't know if this one is a 3 foot or not, but it's a 3 foot space where all the utilities fit in. So the idea was, in the science building, say it's set up to do certain kind of science, but that goes away. It's like when we did the Benson building. We got the Benson building done and beautifully done and right up to date, and we loved it. 3 years later, they changed the way they used hood technology in teaching. And so they came around the department and said, we can't use these new hoods anymore to teach what we need to teach. And we looked at it and said, oh, you're right. And so we had to come in for $1.2 million and replace all the hoods that were perfectly good hoods. In fact, we sold them to someone else. They were perfectly good hoods, but because the useful life of them became zero, we had another problem. But when we installed them, we had all of the space up above, so we could add all of the things required and take away all of the other things that were not required. And so the renovation of it was really cut in half. It was just mainly an equipment purchase and install, rather than having to have a remodel. And we try to do that in those kinds of spaces, Andy, because they're just, you have to remodel it if you don't, and remodeling is horribly expensive.
So the laboratory, the way you put those things in the ceiling, you can create new walls for a lab space and drop the services
Yeah.
down into it.
That's the design.
Where do you need that space? And when that becomes obsolete, then you just tear up the walls.
Or you've got a 6-month project, we're in the middle of the project, comes open space, and somebody else builds a lab, and so we come in and hook the lab up. The utilities where you want them and then how they function. Not everybody sees a lab the same way. Now, that's not in some of our old labs. That's really in the new stuff we're doing. It's all based on certain quarters and certain ways to build. So let's get back to the question of life cycle. Because I think in your industry, you need to be the inspiration to build something that you can retrofit and get the maximum life out of it, rather than just get the project done, okay? How do you do that? With all the time pressures and so on, Andy, how do you build something that you know you can take care of for a long period of time, but the industry is only so much dollars and you only have so much time?
It seems like a beginning point would be to identify the factors of your design that are likely to change over time.
Yeah.
And somehow design yourself free of those factors, like Noah's Ark. You float above the flood, and when the water resides, you come down and you're still okay in the ark.
If you can get that into your product, you will spend money on the front end, but you will have a product that will last for a long time. And so, is that good for your industry, Andy, to have it last, or is it better to die out and start over?
It's becoming very commercial these days.
Okay?
Entrepreneurs are getting into education, whereas before it was all done maybe in a professor's office or in the university lab or something like that. Nowadays, entrepreneurs are building products and they're taking total cost into account. They have to. One of the things that would be helpful is if the students could name a few of the factors that they see that are likely to change. Where are these shear points, as it were, in the technology of their products? What changes that affect your product?
Content.
The content can change, new discoveries in the field or new ways of looking at it. What else?
Sometimes graphics can look old really quickly.
Graphics can look old real quick, graphical styles. So if you could lift those off somehow and put in new ones, okay, what else?
Presentation technology changes rapidly.
Like this.
Projector, touch screen, color screens.
Well, on the other side of that,
LEDs,
Brett,
screens.
the languages that you're using, the actual software changes.
Software languages change, operating systems change.
Demographics in ours changes a whole lot.
Absolutely. And where they use them. We're going mobile these days. We've got phones, we've got mini pads, we've got pads, we've got laptops. Everything's in a turmoil. Everything's in change. How do you design in that?
That's the question.
Yeah.
That's the handle, but we continually try to redesign. We have a book, I think it's still online, maybe we've hidden it so no one else sees it, but it's called Instructions to Architects and Engineers. And it's just a nice way to say, you're working for us, not for yourself. We've discovered we're down to 3 elevators now, those are the ones we'll buy. Because it's the only ones we're trained in, parts for, and it's maintainable. Everything else is going in a what they call a black box, which requires you to have them do everything. So now an elevator gets stuck, it may take you an hour or 2 hours to get somebody here to take care of it. We don't like that. You've only got a 10-minute break between classes anyway. So we like to be able to take control of it. We can get it cheaper, we can get it better, And so far, the return on that kind of an elevator is way, way ahead of returns on the normal kind that cost a lot of money to service and so on. Well, since PowerPoints are outdated, should I say it that way? That's why I love this conversation so far, just so I don't have to deal with PowerPoints, but that's what I brought, so. Any questions before we move on? Now, what I want you to think about is not buildings and how this affects buildings. I want you to think about, if I had a product here, how would I deal with this subject? Because these are principles I'm teaching you, these are common to any kind of an asset, and you're gonna build assets. Your assets just happen to be things that have either short or long life cycles and very much creative and so on. But things change. And if you look at it in your profession as a one-time job, I do it and I'm done, I'm out of here. I don't know how successful you'll be. You may be good in getting jobs done and making money, but you may not be very good at keeping everything fresh and up to date and new and better. We experiment at times with buildings and put certain things in. At the technology building, the new one, we put foam first time in all the walls, just to see what we could get. And then we use triple pane windows to see if we get energy. Then we cover the ceiling. And so we turned on the fan, which was circulating fan and so on, and we couldn't shut the doors because it was so tight that there was, everything that we planned on for loss in the building wasn't there. So we had to go back and reprogram the whole fan system, and it found out that we could use half the fan's timing that we were on to take care of that building. And so, what's our standard? Well, you look at the windows, you look at the ceiling, you look at tightening the building, and there is truly savings there if you spend the time and the money to do it. It costs us just a design cost, because everything we were doing there was already part of the material cost. You'll find out those little secrets. You'll find out how being ahead of the game and planning everything a little ahead of the game so that you know it's there, I think will pay you dividends in the field. Is that right, Andy, or am I
Absolutely.
wrong? Okay. And then any gains you have, you can do like Andy, from 750,000 down to 85,000 with technology.
Yes.
Let me ask just a couple of questions and see if you can answer. When Age first started, what was the main purpose of that Age?
That is when the first product was built.
Could have been, what was the first product?
The 750,000.
No, I'm talking Earth. When we first, think of Adam and Eve, and then a few years later. What kind of industry were they in? What was their purpose during that time frame?
Suppose they were agricultural.
Right? They were all about food for themselves, providing for themselves. If they had any extra, Aunt would sell it. But mainly it was to provide for themselves. It went that way up until the industrial age started. Andy, when was that?
Wow. If you're talking about use of bronze metals,
Yeah,
Bronze Age?
and just the manufacturing concept where you could now build multiple things, like multiple cars. Ford was one of them,
oh yeah.
and some of the others started this idea that we can mass produce. As long as you like black, we can give you everything you want, you know?
The foundations of that industrial age were in about 1850,
Yeah,
and it really picked up at the end of the 1800s
yeah,
and has been accelerating ever since.
yeah. And so the industrial age, what's the purpose of the industrial age?
Do you wanna know the real answer?
Yeah,
Fight better wars.
that was probably the driver.
Most of the innovations, most of the inventions came about as a result of needing to win a war.
Maybe going to the moon, I mean,
Yeah.
some.
Going to the moon. Yeah.
But there was a driver, there was something that was making that age be even more productive, but the goal was to make money, right? So here you were a farmer, and then all of a sudden you now have the goal of making money, which made education more valuable, because collectively we can teach and everybody got to be successful and make more money living in the industrial age. Who won in the industrial age? Who are the big successful groups in the industrial age?
The financiers.
Financiers took a little back seat to these guys. What I'm thinking of is big companies that could start controlling things, controlling markets. And that's when the General Motors and all of that started taking place, because they were just starving for a bigger bottom line and so on. What happened, when did the next age come in?
About 1950.
And what was that?
Digital.
Yeah, it was first a digital kind of a thing, and then it became more of an information age. And so you'll hear information age as being so long. So the industrial age lasted how long?
Well, from about roughly the modern version of it, 1850 to about 1950, about 100 years.
Yeah, about 100 years. Now we're in the information age. Are we past the information age?
Not until Moore's Law runs out.
We actually, according to the professionals, you know, sometimes you question, but we are out of the information age. Because all the information was about how do you get everything digital and make money doing it. Okay? Now we're in a different age. What do you think the age is that we're in right now?
I can tell you what I think it is.
What do you think it is?
Design age.
Could be, that's part of it. What else?
Innovation age, kind of the same, similar kind of thing.
Somewhat of an innovation, but they claim, and this is everybody that's smart, says that we're really in the communication age. That everything's about communicating. With the cell phones, with anything we have, we ought to be able to see, know, and pass on and deal with and talk to. And that's way beyond just getting information. This is a sharing kind of a world we're in. And so, if you're in this age, you certainly don't want to design something that's in the information age. You want to do something around the communication age. What's the next age?
We'll see.
Go ahead.
I just got the second coming, but.
The millennial age.
Yeah,
If, you know, I have one of my favorite writers is a guy named Krippendorf, who's back in Penn State and the School of Communications there. And if I were to look, you know, he describes the evolution of products through
yep,
self-contained products, through
Yep.
socially defined products. Near the top of his ladder, as it were, is the kind of product where somebody uses the communication capabilities to build a space, a workspace, a virtual workspace, and create a task within that space that everybody contributes to, like Wikipedia, as an example, where all of a sudden something appears, some useful thing, artifact appears that wasn't there before because people came together to perform a task together. So
Yeah.
maybe it's the cooperation age.
I think you've hit closer to what I think it's gonna be as well. They haven't named it yet. They talk about this next age, but it's about how do we make you successful? In other words, now you communicate anything you want, the information age is already behind us. What are you gonna do with communications? And a lot of them are saying it's just now a focus on how do you make a difference so that you, I call it provide for the family, provide whatever else, but make you the commodity that everybody wants to do something. And no one's named it yet, but everything you see is focusing towards how to make you the smartest person you can, so you can be the most successful you can. And is that a combination of schooling and technology? Yeah, who knows? Yeah.
There is an interesting book that borders on, that touches on what you're talking about, and it's by Peter Drucker,
Yeah.
who's the business magnate. And the book is called The New Reality, or The New Realities, I can't remember which.
Is it Nebeker? No. Also wrote about that.
Oh, is that right?
But yeah, everybody's talking about, because you can't stay in there's no value in being in the communications age. Because talk is cheap, and talk is everywhere. All talk does is make the government figure out whether you're a spy or a native or a friend. But communicating between whoever you communicate doesn't always make money. The people that make the money are those that provide the tools to talk. But, well, how do you run a university in the communication age? That's where we're struggling, because it keeps moving faster than we have resources or time. Well, I spent all my time. What time do you go to lunch?
Right about,
About 12:30?
no,
Oh,
actually,
1:30?
at about 12:50,
We're about there.
yeah.
And I did show you one slide. Can I tell you that we covered all the topics? Because I wanted to have a discussion about this so that you knew leaving here what total cost of ownership really meant. And that you have a challenge to see how it fits into what you're doing. I'll close by saying some of the roadblocks you'll run into is this idea of getting it done quickly and moving on. Because that's a carryover of the industrial age, it just hasn't left us. The information age is more like where we're at, that we do want to track details of what it takes over time. But in reality, I looked one time at all of the assets that BYU has. In fact, I was over all the BYU ones, the Idaho, the Hawaii, the Jerusalem Center, all of those assets. I sat down one day and looked at them, I said, and I realized this is just, I looked at all of the assets that I started or had anything to do with during my 40 years at BYU. And then looked at all the assets that I didn't have anything to do with. In other words, they were before us, and we either replaced or replaced. And then I looked at all the assets that I still haven't had anything to do with, that somebody else put here. And I was just awestruck that even though 40 years is a pretty good chunk of time, when you're dealing with life cycles and buildings and things that last a long time, the impact I had on all of the buildings is very little. But I had a pretty good impact when you took the number of lines we went through. And hopefully someday you can do the same. You can look back and see. The point being is, your life is only one sliver of the impact of what you'll have in the industry. And so make it worthwhile. Be the one who figures it out. Be the one who pushes your product standard to be something that everybody wants to have. And then not only will you be successful, but you'll be satisfied that you contributed something through those 40 years to wherever you are at. And I hope that that's your outcome. And I think these slides were available last time we met,
Mhm.
and if you want to review those, I'd be happy to answer any other questions since we didn't go through them, but trust me, it all related to what we talked about. Any last questions? Yes,
How close was your estimate?
two?
You had this, you were gonna project what it would take to run BYU. How long did it take for that to break down in terms, in when reality hit?
How long did it break down? Well, we gave the church a 50-year life cycle average cost. And we said if you paid this amount every year, we could cover all the replacements on campus. And when they looked at the number, they couldn't quite believe it was that low, because they were expecting, because they spend so much money on a new building, they were thinking bigger than that. But then we showed them the reality of what the value of the database was and the replacement value. This campus runs right now about $2.3 billion just in replacing buildings and systems and stuff. That shocked them. But when they saw that we had this line that would cover every replacement and keep every building up to date and so on, they agreed that they could live with that amount of money. And so we have been following that line, gets inflated, and any new buildings get added. But we're up to a number now. We still haven't asked them for any more than that. And we actually have a bank that we save. If we save any money, we put it in the bank so we can spend it when we go over. We only use the bank twice. So in reality, it's been a very successful program. The church adopted it for the church, and temples and everything else. And now they're adopting it for all their equipment, equipment that they have throughout the world. And so principles are there. It's gonna look different than what ours looks like, but there, all the principles, total cost is there. One cute story, President Hinckley, when we were going in to give him this program, President Bateman at the time, who was a friendly guy some days, brought us in and said, before you go before the Board of Trustees present this, I want to tell you that I don't want you presenting any big numbers that would foul up anything that we're trying to build or raise in the future. You can talk about averages and all that, but I don't want to hear any big numbers. And I said, President, it doesn't work that way. We have to show the total cost, because our whole presentation was based around one building, what the total cost of that building was. And he said, just show them the concept, but don't show them the numbers. And so for the first time, I thought I lost my job, by the way. I said, President, got to show them the numbers. And he said, well, these people will never fund anything again if they know what the total cost of a building is. And so, to make a long story short, we went and made the presentation, showed President Hinckley what the total cost of ownership was. He hit the table with his hand. I thought, oh no. Prophet, I should have listened to Bateman, got up and said, this is the first time in my life I feel comfortable about approving a new building. Because he said, in the past, I never knew what it was going to cost us, and said, I want this program to be refined and to be taken. And the funny thing was, about 2 years later, President Bateman went in to try and get some of the funding that was being used to maintain buildings for a program. And President Hinckley just gave him a Scotch blessing and said, I don't trust presidents to maintain their buildings when all they want to do is build new ones. And so, it's been a fun trip. And past time, thanks.
Thank you, Doug. Thank you very much.